Hello grade 12s, my name is Natasha Barton and I would like to welcome you to this video in which we will be taking a look at question number 1.1 to 1.3 of the November 2021 Physical Science Paper 1 exam. We start off with question number 1.1 which says, consider the statement below. The perpendicular force exerted by a surface on an object in contact with the surface. Which one of the following forces is defined by the above statement? Is it the normal force, resultant force, frictional force, or gravitational force? Now, grade 12s, it is very important that you learn all of your definitions off by heart according to exam guidelines, and it is best that you learn them word for word. Therefore, you should easily know that the answer to this question is A, the normal force. The normal force is exerted by a surface onto an object, of course, in contact with that surface, and it is exerted at a 90-degree angle. If you were tempted to say frictional force, please remember that the frictional force acts parallel to the surface and in the opposite direction to the motion of the object. We now move on to question number 1.2, which says, two balls of masses m and 2m are dropped simultaneously from the same height above the ground. Ignore air resistance. When the balls strike the ground, which means they're going to hit the ground, which one of the following physical quantities will be the same for the balls? Will it be the weight, the velocity, the momentum, or the kinetic energy of each ball? Before we come to the conclusion about which answer is correct, let's analyze the information that has been given to us. Firstly, we see that each ball has a different mass. The one ball is has two times the mass of the other ball. They are dropped, and the word dropped implies that they both start off with an initial velocity of 0 meters per second. They dropped simultaneously, which means they dropped from the same time. And they both start off from the same height and will both hit the ground, so we know that their displacements are the same. The only thing so far that is different for the two balls is their masses. Now, let's look at the different options that we have. To calculate weight, we say Fg is equal to mg. To calculate velocity, we use equations of motion, especially in the section on vertical projectile motion, because the objects are traveling in a straight line. To calculate momentum, we say P equals mv, where P is the momentum of each object. And to calculate kinetic energy, we say Ek, which is the kinetic energy, is equal to half mv squared. Now, if we analyze each of these formulae, we soon notice that weight is dependent on mass, momentum is dependent on mass, and kinetic energy is dependent on mass. But how about the equations of motion? Well, none of the equations of motion contain the symbol m, which means they're independent of mass. Therefore, when we calculate the velocity with which each ball will strike the ground, we are not going to make use of their masses. We are given the initial velocity, the displacement of each ball, and we know acceleration is a constant 9.8 meters per second down. Since this part of the formula for each ball is exactly the same, we can come to the conclusion that they will hit the ground with exactly the same velocity. And therefore, grade 12, the correct answer to this question is B, the velocity of each ball. They're going to be exactly the same. We often think that a bigger object is going to travel faster towards the ground. But here you can clearly see that the velocity, especially in the absence of air resistance, is going to increase by the same amount for each ball. That is the gravitational acceleration of 9.8 meters per second squared. We now move on to the last problem in this video, which is question number 1.3. It says the graph below shows the momentum of an object, or how the momentum of an object changes with time. So we can see we have a beautiful graph, and on that graph, on the y-axis, we have momentum, and on the x-axis, we have time. They say during which one of the following time intervals, measured in seconds, is the magnitude of the net force acting on the object the greatest. This means the biggest. We have 0 to 1 second, 1 to 2 seconds, 2 to 3 seconds, or 3 to 4 seconds. Now, the physical quantities that we are dealing with in this question is momentum, symbol P, time, symbol T, and the net force, which is given the symbol F net. Our question is, what is the relationship between these three physical properties? And if you have forgotten, you can always go back to your definitions. You can also go to your formula sheet and see if you can see anything. Well, these three quantities should remind you of Newton's second law of motion in terms of momentum, which I'm displaying to your screen, and this formula over here. If we manipulate that equation, then we have that F net is equal to change in momentum divided by change in time. In other words, we have P final minus P initial over T final minus T initial. That is assuming that we don't start off with a time of 0. Now, if you look at this formula and look at your graph, you may very quickly see how this formula relates to your graph. P is on the y-axis. It is a y value as far as mathematics is concerned. If we look at time, we see that time is on the x-axis, right? So when we look at a graph and we would like to gain valuable information from the graph, we may consider calculating either the gradient of the graph or the area underneath the graph. This formula is in fact the gradient of this specific graph. So what that means, grade 12s, is that we can calculate the gradient over here to determine the net force, over there to determine the net force between 1 and 2 seconds, over here between 3 and 2 seconds, and lastly over here between 3 and 4 seconds. If we determine the gradients of each of these sections of the graph, we will determine the net force acting during the different time intervals. Now on the right hand side of your screen, you can see I've calculated the different gradients or net forces. For the first section, we see that the net force is 20 newtons. Then between 1 and 2 seconds, we have that the net force is given as negative 10 newtons. Its magnitude is 10. Between 2 and 3 seconds, the net force is given as negative 20 newtons, or its magnitude is 20 newtons. And during the last time interval, 3 to 4 seconds, the net force that we find is 30 newtons. Of course, 30 is bigger than all of the other magnitudes, and therefore we know the answer to question number 1.3 is D, 3 to 4 seconds. You could also answer this question by simply looking at the different gradients of the different sections of the graphs. But if you look just at first glance, it looks like these gradients are the same. So I wouldn't do that. I would actually calculate the gradients as I have done and use the answers to determine the answer to a question like this. Grade 12, this brings us to the end of this video. In the next video, we will continue with this multiple choice section.